Imagine a serial killer that successfully murdered tens of millions of victims across an entire continent and did it in under a decade.
Yeah, and imagine the murder weapon wasn't, a virus or some deliberate bioweapon. It was just a basic over-the-counter painkiller.
Right. It's crazy. Welcome back to another deep dive, everyone.
Glad to be here.
If you're listening to this, you are probably someone who loves overturning common assumptions. And today's mission is, well, it's absolutely guaranteed to do just that.
Definitely. It's a wild story.
We are heading into a biological landscape that I think most people, honestly, try to actively avoid looking at. We're talking about the highly misunderstood, heavily maligned, and just absolutely critical world of vultures.
Yeah, nature's ultimate unappreciated cleanup crew.
Exactly. And to do this, we've pulled together this massive stack of sources. We've got historical and ecological Wikipedia articles, field conservation protocols from Vulture.
Which are fascinating, by the way.
Right. And we also have the primary scientific reports on the Asian vulture crisis, plus updates from the Vulture Conservation Foundation and DOF BirdLife. So our goal today, our mission, is to completely transform how you view these birds, from, spooky symbols of death to the essential guardians of human and ecological health.
Because that's really what they are. Guardians.
Okay, let's unpack this. Because to understand the scale of that continent-wide murder mystery we mentioned, we have to start with the victims themselves.
Right.
And the way we view vultures today as these, gross, creepy harbingers of doom, that's actually a really modern cultural invention.
It really is. I mean, if you look back at the archaeological record, you see this completely inverted perspective. Like, look at ancient Egypt.
Yeah, the sources talked about that.
Right. In ancient Egyptian iconography, you do not see vultures depicted as grim reapers. They revered them as symbols of immaculate motherhood, of purity.
Purity. That is the exact opposite of what I'd think of.
I know, right? But they saw them representing the cyclical nature of life, turning death into life.
I was looking at these images of New Kingdom royalty, specifically the great royal wives, and they're wearing these elaborate crowns. They look like birds just draped over their heads. I was assumed they were falcons, but they're vultures.
Yes, specifically the goddess Nekhbet.
Right, Nekhbet, the patron of Upper Egypt. And she was literally depicted as a griffin vulture, or sometimes a lappet-faced vulture.
Yeah.
Why would a civilization that was so obsessed with purity and the afterlife put a scavenger on their highest pedestals?
Well, it comes down to observation. The Egyptians watched vultures descend on rotting, putrid carrion stuff that meant disease and death to a human, and they just consumed it without any consequence.
Just ate it, we're totally fine.
Exactly. They witnessed this profound ecological alchemy. The vulture took death and waste and miraculously transmuted it into living tissue, into flight. They even believed that all vultures were female.
Wait. Really?
Yeah. They thought they reproduced spontaneously without males, which cemented this whole idea of immaculate self-generating motherhood. They didn't see an eater of the dead. They saw the ultimate purifier.
Which is, it's a beautiful conceptual framework, but obviously they aren't reproducing by immaculate conception.
No, definitely not.
And they aren't performing magic. It's just highly specialized biology.
Yeah.
But this is where the evolutionary tree gets incredibly weird. Because the term vulture is essentially a functional illusion.
Yes, it's a catch-all term.
Right, for two distinct lineages of birds that aren't even closely related.
Yeah, it's one of the most striking examples of convergent evolution we have. You've got the old world vultures, so that's Africa, Asia, Europe. Taxonomically, they belong to the family Accipitridae.
Which puts them in the same family as eagles and hawks.
Exactly. But then you cross the Atlantic to the Americas, and you find the New World vultures.
The family Cathartidae.
Right. And genetic sequencing proves they split off millions of years ago, completely separate, but functionally and morphologically, they are dead ringers for the Old World species.
So it's like two different tech companies, right? Separated by an ocean, independently inventing the exact same smartphone because the market just demanded it.
That is a perfect analogy, yes.
But why did nature demand this exact biological design twice? Why this specific blueprint?
Because the environmental pressures on both sides of the globe were identical. The biome offered this massive caloric resource, dead large animals, basically. But to get it, you need a highly specific anatomical toolkit.
Right.
Evolution arrived at the exact same design twice because the physics of being an obligate scavenger demand it.
Okay, but I have to challenge the idea that a bald head is an absolute non-negotiable requirement. Because, okay, if you were a Ruckelpels vulture soaring at like 37,000
And
feet,
it's incredibly cold up there.
exactly, stripping the insulation off your head and neck seems like a terrible evolutionary trade-off.
It is a trade-off, but it's driven by the mechanics of feeding and thermoregulation. Think about it. When a large scavenger eats, it's frequently plunging its entire head and neck deep into the visceral cavity of a decaying animal.
Oh, gross.
But yeah, if that head were feathered, the plumage would immediately get saturated with coagulating blood, tissue fluids, massive bacterial loads.
They can't exactly wash their hair.
Right. Feathers trap all that material, creating a breeding ground for pathogens. Bare skin, on the other hand, allows all that biological debris to just dry up, flake off, or get sterilized by the UV radiation from the sun.
So it's mostly an adaptation for basic hygiene.
Hygiene, yes, but primarily thermodynamics. That bare skin functions as a highly vascularized thermal window.
A thermal window.
Yeah.
Yeah.
Vultures generate immense metabolic heat when they digest a huge meal or when they're fighting at a carcass. They use their bare heads to dump that excess heat. If you look at them on thermal imaging, their heads literally glow.
Wow.
And conversely, if they're in freezing temperatures at high altitudes, they just pull their necks back, tucking their bare heads deep into their collar feathers.
Like zipping up a jacket.
Exactly. It effectively closes the thermal window.
That's incredible. So the structural convergence makes total sense, but their internal avionics, like their sensory arrays, those are completely different.
Totally different. Old world vultures operate almost exclusively on visual telemetry. They catch thermal updrafts, get incredibly high, and just use raptor-grade vision to spot a carcass miles away on the open savanna.
But New World vultures use a completely different sensory paradigm. They rely heavily on smell.
Yeah, olfaction, which in the bird world is remarkably rare.
Right, birds aren't exactly known for sniffing things out.
Exactly. Yet the turkey vulture has a massively hypertrophied olfactory bulb. It's specifically tuned to detect ethyl mercaptan.
Ethyl mercaptan. That's the gas produced during the initial stages of decay, right?
Yes, the very first signs of rotting meat.
The sources noted they can detect that gas from up to a mile away and navigate through the dense canopy of a South American rainforest.
Yeah, through multiple layers of canopy.
I just struggle to understand how wind currents even carry a reliable scent plume through a jungle to a bird soaring way above it. Like, how does that physical mechanic work?
It's all about convective currents. As the jungle floor heats up during the day, the warm air rises. It carries the ethyl mercaptan up through the leaves and out into the open air above the forest.
Okay.
Then the turkey vulture flies in these low, sweeping patterns, basically mapping the invisible topography of the scent plume in the air. Once they hit the highest concentration, they drop right down through the trees to the forest floor.
That's wild.
And what's funny is because they are so efficient at this, other New World vultures that don't have this sense of smell, like the massive king vulture, they will just shadow the turkey vultures.
They just follow them.
Yeah. They let the turkey vultures do all the olfactory legwork, and then they swoop in and use their size to dominate the carcass.
Nature's freeloaders.
I love it.
But locating the food is really just the logistical preamble. The actual physiological marvel is what happens once they eat it.
Oh, definitely.
We are talking about birds routinely eating tissue that is heavily colonized by anthrax spores, botulinum toxin, hog cholera. If my dog ate that, it would be instantly dead.
Any other mammalian scavenger would experience rapid, catastrophic mortality, but the vulture treats it like a standard protein shake.
Because their stomach acid sits at a pH of 1.0.
Yes. And the biochemical hostility of a stomach at a pH of 1.0 really cannot be overstated. For context, a human stomach fluctuates between 1.5 and 3.5.
And the pH scale is logarithmic, right?
Exactly. So a drop to 1.0 means the vulture's gastric environment is roughly 10 to 100 times more acidic than ours. It's an absolute biochemical incinerator.
But wait, how does the stomach lining itself survive that? If you drop raw meat into an acid that strong, it dissolves. And the vulture's stomach is made of meat. How is it not digesting itself?
It's an intense arms race of cellular regeneration. The cells in their stomach lining are aggressively pumping protons into the gastric lumen at a huge energy cost. But to protect the tissue, The stomach secretes this phenomenally thick, highly alkaline mucus barrier.
Ah, so it neutralizes the acid right at the wall.
Right at the cellular boundary, yes. Plus, the cellular turnover rate in their gut is hyper-accelerated. But the evolutionary payoff for all this energy expense is total pathogenic immunity. When an anthrax spore hits that acid, it completely denatures the protective protein coat, destroys its viability.
So they're essentially sanitizing the environment by eating the worst things imaginable.
Exactly.
Which brings up some of their more, let's call them jarring physiological adaptations for dealing with bacteria outside their stomachs.
Yeah.
Specifically, urohydrosis in New World vultures.
Right.
They routinely urinate directly down their own legs.
Evolution is endlessly pragmatic. Think about it. When a vulture is wading through a ruptured carcass, its legs are exposed to massive amounts of aggressive pathogens.
Sure.
Avian waste is highly concentrated with uric acid. So by excreting this semi-liquid uric acid down their legs, they achieve a dual-purpose mechanism. First, the high acidity acts as a harsh topical disinfectant. It destroys the bacteria clinging to their scales.
Like hand sanitizer for their legs.
Exactly. And second, as the liquid part evaporates in the heat, it draws thermal energy away from the blood vessels in their legs. It provides rapid evaporative cooling to drop their core body temperature.
It is deeply pragmatic, I'll give you that.
Mm-hmm.
But it's also visually horrifying, kind of like their emergency response to a predator.
Ah, the vomiting?
Yeah? If you startle a feeding vulture, it will violently vomit. I had always read this was a defensive projectile weapon, like weaponized acid and rotting meat designed to blind or deter a predator.
A lot of people think that, but it's a pervasive myth. The vomiting is purely mechanical, not tactical.
Really?
Yeah. Vultures are heavy-bodied birds with high wing loading. When they feed, they absolutely gorge themselves, packing their crops to maximum capacity. This added mass makes them dangerously sluggish.
So they can't fly away fast enough.
Exactly. Yeah. If a hyena or a feral dog charges them, they need instantaneous vertical lift. The vomiting is just a rapid jettison protocol.
Oh, wow. They're just dumping cargo.
Precisely. They're dropping payload to instantly reduce body mass, altering their power-to-weight ratio just enough to get airborne.
Mm-hmm.
If the foul-smelling ejection happens to distract the predator, that's just a lucky byproduct. The real goal is mass reduction.
That makes so much more sense than them trying to aim a vomit cannon. Okay, so if their physical machinery is perfectly optimized to consume and neutralize lethally infected tissue, the natural consequence is that they act as a biological firewall for an entire ecosystem.
A biological firewall. I like that.
Yeah, they provide what ecologists call ecosystem services, the unseen, free labor that sustains the environmental balance. And outside of the oceans, they are the only known vertebrate obligate scavengers.
Right. They are the ultimate endpoint for biomass. And the mechanical efficiency of a wake, that's the term for a group of feeding vultures, is staggering.
The sources gave a really visceral statistic for this. A wake of roughly 100 white-rumped vultures can strip a 45-kilogram carcass down to bare bone in under 3 minutes.
Under 3 minutes, yes.
3 minutes for 100 birds to consume 100 pounds of meat. The biomechanics of that feeding frenzy must be highly synchronized. They can't just be blindly tearing at it.
No, it's a highly stratified competitive sequence. Smaller vultures frequently arrive first, but they can't breach the thick hide of an intact cow or elephant. They actually need a larger, specialized counterpart to arrive.
Like the lappet-faced vulture in Africa.
Exactly. The lappet-faced has a massively reinforced beak designed specifically to shear through thick tendons and hide. Once they breach that structural integrity, the smaller, deeper-reaching vultures swarm the internal cavities and strip the soft tissue.
And once the soft tissue is gone, the niche specialization goes even deeper, because you have the bearded vulture, an animal that looks more like a mythological griffin than a traditional vulture, and it eats bone marrow.
Yeah, up to 90% of the bearded vulture's diet is bone. Their strategy eliminates the need to compete at the fresh carcass.
Because they just wait for everyone else to finish.
Right. They wait until the wake has completely skeletonized the animal. Then they swallow smaller bones whole. Their esophagus is exceptionally elastic, and their stomach acid can dissolve a solid sheep vertebra in 24 hours.
That's insane. What about the big bones, like leg bones?
For the massive ones, they use gravity. They pick the bone up, catch a thermal, and drop it from extreme altitudes onto specific rocky slopes called ossuaries. The bone shatters on impact, exposing the lipid-rich marrow inside.
Okay, we also have outliers that completely abandon the carrion model altogether. You mentioned the palm nut vulture earlier in our notes.
Yes, the palm nut vulture in sub-Saharan Africa, it derives up to 65% of its calories from foraging oil and raffia palm fruits.
A vegetarian vulture. Wild. And we have to talk about the high flyers, too. The Rappel's vulture. There is a documented strike between a Rappel's vulture and a commercial aircraft at 11,300 meters.
Over 37,000 feet.
Yeah. The atmospheric pressure up there is incredibly low. The ambient temperature is lethal. How is a bird's cardiovascular system sustaining powered flight in the death zone?
It requires a profound hematological adaptation. The Rappel's vulture possesses a specific mutation in its hemoglobin structure, specifically a variant in the alpha-D subunit.
Okay, what does that do?
It gives their blood a dramatically higher binding affinity for oxygen. They can efficiently extract and transport oxygen at partial pressures that would instantly render a human unconscious from hypoxia.
These biological extremes are just fascinating. But the real-world application of this scavenging translates into massive economic infrastructure.
Oh, absolutely. The economic value is huge.
The Spanish agricultural sector is a perfect quantitative model for this. Spain currently has the most robust vulture populations in Europe. And their griffin vultures act as an integrated, free disposal system for the livestock industry.
And the math on their ecosystem service is irrefutable. When domestic livestock die on rural Spanish farms, the griffin vultures consume the carcasses right there in the field. Researchers calculated the logistical alternative, and it's bleak.
If the vultures weren't there.
Right. If they were absent, farmers would be legally required to physically collect, load, and transport these massive, rotting animals via heavy diesel trucks to specialized industrial incineration plants.
And the financial and environmental cost of doing that is staggering.
Huge. By allowing the vultures to perform this natural incineration, the Spanish agricultural sector saves an estimated $50 million annually. That's just in transport fees and insurance premiums.
$50 million.
Yeah.
Just by letting birds eat.
Yeah.
And more importantly, eliminating those diesel truck routes and the energy-intensive incineration process cuts greenhouse gas emissions by over 77,000 metric tons of CO2 every single year.
So they are actively offsetting carbon emissions by eating dead cows.
Exactly.
So we have an animal that neutralizes anthrax, dissolves bone, flies at commercial cruising altitudes, and sustains the agricultural economy. They seem biologically invincible.
Which is exactly what makes the forensic mystery of the Asian vulture crisis so chilling.
Because it was exactly this. Efficiency, their role as the ultimate processors of our agricultural waste, that exposed them to a synthetic vector they had no evolutionary defense against.
Yeah.
Let's lay out the timeline of this collapse, because the sheer speed of it just defies logic. In the late 1990s, the Indian subcontinent hosted the largest raptor populations on the planet.
Massive populations.
Yeah.
Right. Hindu cultural and religious traditions heavily venerate the cow. They are integral working animals, and upon death, their biomass is generally not processed for human consumption. This created a colossal, continuous conveyor belt of carrion left out in the open.
And the vulture populations expanded to meet this caloric surplus, particularly the oriental white-backed vulture. By the 1980s, their numbers were estimated in the tens of millions. They were so ubiquitous across the urban and rural landscapes that they were effectively treated as background noise.
But then, that background noise just stopped.
Yeah.
And I have to wonder, how do you lose tens of millions of large, highly visible birds without immediately noticing the drop?
The sheer vastness of the population actually masked the initial decline.
How so?
Well, if you have 10,000 birds circling a city dump and you lose 3,000, the sky still looks full to the casual observer. The first empirical alarm was actually sounded by Dr. Vibhu Prakash.
Ah, right, in Kiladeo National Park.
Yes. He had been conducting rigorous long-term monitoring there in Rajasthan. His historical data from the late 80s documented 353 breeding pairs of oriental white-backed vultures within the park.
353.
When he repeated the survey a decade later, that number had collapsed to 20 pairs.
Wow.
And by the next breeding season, it was 0.
And the data from other species was equally grim. Long-billed vultures in the same park dropped from 816 individuals down to 25. Once researchers began aggregating data across India, Pakistan, and Nepal, the terrifying reality crystallized.
They were witnessing a 99.9% population crash across an entire subcontinent in less than a decade.
I look at those numbers, and I immediately assume a highly virulent airborne pathogen, like a mutated strain of avian influenza spreading through their dense roosts.
That was the immediate hypothesis of the international scientific community, too. In late 2000, an intensive epidemiological investigation launched in Pakistan's Punjab province, led by a team including veterinary microbiologist Dr. Lindsay Oakes.
Right.
They began recovering fresh carcasses and conducting extensive necropsies, searching for an infectious agent.
But the pathology reports didn't show a virus. They revealed a specific, severe physiological failure.
Yeah. In roughly 85% of the adult carcasses they examined, they found advanced visceral gout.
Visceral gout. Now, what exactly is that? Because people hear gout and think of like a swollen toe.
Right, it's completely distinct from the localized articular gout humans experience in their joints. In these birds, the internal organs, the heart, the liver, the spleen, were entirely encased in a thick, chalky white paste of crystallized uric acid.
Meaning the kidneys had catastrophically failed.
Exactly. Avian kidneys are responsible for filtering uric acid from the bloodstream. If the renal system shuts down, the uric acid just continues to accumulate in the blood until it reaches supersaturation.
And then it physically precipitates out of the blood and crystallizes onto the organs.
Yes. But the exact cause of that kidney failure was fiercely debated. Many researchers argued the gout was a secondary artifact. They thought a novel virus was causing severe enteritis, leading to massive fluid loss.
So they thought the birds were basically dying of dehydration, which caused the kidneys to fail.
Right. But Dr. Carol Meetire, a wildlife pathologist analyzing the tissue samples, pushed back on the dehydration theory, based on what the cellular structure actually looked like under the microscope.
Because the histological evidence did not support a slow failure.
Exactly. Dehydration causes a specific pattern of cellular degradation, starting in the lower ureters. But Dr. Meetire observed severe acute necrosis in the renal cortex. The cellular architecture of the kidneys had simply died overnight.
So it wasn't a virus.
No. There was no widespread inflammatory response typical of an immune system fighting an infection. It was a chemical burn. Something was directly and acutely toxic to the kidneys.
Which leads to the pivotal breakthrough. Oakes and Meetire are reviewing these slides at a conference, and they recognize this specific necrotic signature. It perfectly matched the pathology of raptors that had been inadvertently exposed to powerful anthropogenic drugs.
Specifically, non-steroidal anti-inflammatory drugs, or NSAIDs.
But we are talking about wild birds. No one is hiking into the jungle to hand out ibuprofen to tens of millions of vultures. How is the drug getting into them?
Dr. Oakes applied fundamental epidemiological mapping. He looked at the behavioral ecology of the vultures. They are communal roosters, but obligate scavengers of domestic livestock. They leave the roost, feed on a dead cow in a field, return to the roost, and drop dead of renal failure within days.
The vector had to be the cows.
Exactly. The vector was the cows themselves.
So they profile the killer.
Yeah.
They need a pharmaceutical that is widely used by rural farmers, recently introduced to the South Asian veterinary market to match the timeline, capable of surviving the vulture's stomach acid and known to disrupt renal function.
And so the team deployed across the Punjab. They interviewed hundreds of local veterinarians, pharmacists, and cattle farmers. They compiled a database of every pharmaceutical administered to livestock in the region.
And when they cross-referenced that list against the toxicological profile, a single compound emerged.
Diclofenac.
Diclofenac.
It is a highly effective, phenomenally cheap cyclooxygenase inhibitor. An NSAI used to treat inflammation, lameness, and fever in cattle. It hit the South Asian veterinary market in the 90s and became instantly ubiquitous.
Just a routine painkiller. But the pharmacokinetics in an avian system are lethal. So a farmer treats a sick cow with diclofenac to ease its suffering. The cow dies a few days later, and the unmetabolized diclofenac residue remains active in the cow's tissue.
Right.
The vultures eat the tissue. How does a mammalian anti-inflammatory physically trigger total kidney failure in a bird?
It comes down to how different species metabolize the drug. In the vulture, diclofenac actively inhibits the specific physiological pathways responsible for excreting uric acid. Furthermore, it directly induces oxidative stress and toxicity in the kidney cells.
So it poisons the kidney cells while simultaneously stopping them from doing their job.
Yes, and even trace amounts of microscopic residues in the liver or fat of the cow are sufficient to trigger this cascade. The kidney shut down, the uric acid precipitates, and the bird dies of visceral gout within 48 to 72 hours of eating.
The scientific community's initial reaction to this discovery is fascinating because they largely rejected it, didn't they?
They did. Dr. Oakes submitted these findings, and the peer reviewers balked.
I kind of understand their skepticism. It is a massive conceptual leap to accept that an entire continent's population of apex scavengers was eradicated by a benign cow painkiller.
It violated the fundamental assumptions of conservation biology. Species extinctions on that scale are traditionally driven by massive habitat loss, targeted hunting, or virulent diseases. The idea that unintentional pharmaceutical runoff could achieve a 99.9% kill rate was unprecedented.
But the toxicology was irrefutable. They tested the tissues of wild dead vultures, and 100% of the gout-positive birds had detectable levels of diclofenac. They managed to trace the deaths of captive vultures directly back to specific batches of treated buffalo meat.
When they finally published in Nature in 2004, it forced the world to grapple with a terrifying ecological reality. What happens when you abruptly remove the central pillar of an ecosystem's sanitation infrastructure?
You trigger a trophic cascade. The environment fundamentally destabilizes. The diclofenac killed the vultures, but the underlying agricultural reality remained. The cows were still dying.
Right. The immense biomass of carrion was still being generated every single day, but the biological incinerators were gone.
So millions of tons of dead livestock are simply rotting in the open sun. And nature will always exploit an available caloric resource. In the absence of the vultures, feral dogs moved in.
And the feral dog populations experienced an uncontrolled explosion. With unlimited access to high-density protein, their breeding rates skyrocketed. Millions of additional feral dogs flooded the urban peripheries and rural landscapes.
Which introduces a catastrophic human health crisis. Because unlike a vulture, a feral dog's stomach does not operate at a pH of 1.0.
No, not at all.
They're not biological dead ends for pathogens. They are highly efficient vectors.
Exactly. Dogs can harbor and transmit a multitude of zoonotic diseases. Furthermore, their behavioral ecology is entirely different. A wake of vultures will immediately fly away if a human approaches a carcass.
They're skittish.
Right. But a pack of feral dogs, heavily invested in defending a massive food source, they will stand their ground and become highly aggressive.
The public health data from this period is horrifying. Dog bites in India surged exponentially. And because these dogs were largely unvaccinated in feeding on infected material, the rates of rabies transmission exploded.
Epidemiologists estimate that tens of thousands of human beings died agonizing deaths from rabies, directly as a result of the feral dog boom, which was entirely facilitated by the loss of the vultures.
The resulting strain on the healthcare system cost the Indian economy tens of billions of dollars. But the collapse rippled far beyond the medical infrastructure, too. It dismantled ancient socioeconomic systems.
Like the bone collectors.
Yes. For centuries, a specialized caste of bone collectors operated in symbiosis with the vultures. When a cow died, skinners would quickly harvest the leather. The vultures would then descend and surgically strip every ounce of soft tissue from the carcass within hours,
leaving behind clean, sun-bleached skeletons.
And then the bone collectors would gather these sterile bones to be processed into agricultural fertilizer or industrial gelatin. But without the vultures, that economic engine seized up.
Because the meat was left to rot?
Exactly. The skinners would remove the hide, but the meat was left to putrefy. It became infested with blowflies and feral dogs, a profound biohazard. The bone collectors could not safely handle the remains, destroying their traditional livelihood.
It also deeply impacted core theological practices, most notably the sky burials of the Parsi community.
I was reading about this. The Zoroastrian faith views earth, fire, and water as fundamentally pure, sacred elements.
Yes. To bury a corpse in the earth or burn it in a fire is considered a desecration of those elements. For millennia, their theological solution was to place their deceased in elevated, open-topped structures known as towers of silence.
And the vultures would arrive, consume the remains rapidly and cleanly, and free the soul without polluting the sacred elements.
But as the diclofenac wiped out the vulture populations, the skies above Mumbai and the towers of silence emptied. The bodies of the deceased were left largely untouched, decomposing agonizingly slowly in the open air.
The sheer ecological absence forced a profound cultural trauma. They had to explore mechanical alternatives like solar concentrators just to accelerate decomposition. It's a stark example of how deeply human culture is tethered to the unseen mechanics of local ecology.
And if we look globally, this dynamic is playing out again right now in Africa. The African vulture crisis is seeing species plummet toward extinction. But the vector isn't a pharmaceutical accident.
No, it's a deliberate tactical poisoning by poachers.
The mechanics of this are so cynical.
Explain how it works, because when a poaching syndicate brings down an elephant or a rhinoceros for its ivory, the extraction process takes time, and they know the park rangers monitor the airspace.
Right. Vultures act as highly visible, high-altitude sentinels. A massive wake of vultures circling a specific spot is a giant beacon to anti-poaching units, signaling a fresh kill. Rangers will deploy directly to that location, frequently intercepting the poachers.
So, to disable that early warning system, the poachers have weaponized the vultures' communal feeding behavior. Before fleeing the scene, they lace the exposed tissue of the elephant carcass with incredibly lethal agricultural pesticides.
Typically cholinesterase inhibitors like aldicarb or strychnine.
And because vultures feed in massive, highly concentrated wakes, a single poisoned elephant becomes an ecological weapon of mass destruction.
The neurotoxins cause violent seizures and rapid respiratory failure. In one documented incident in northern Botswana in June 2019, authorities discovered 3 poisoned elephant carcasses.
And scattered around them were over 500 dead vultures.
537, to be exact. Critically endangered, lappet-faced, hooded, and whiteback species. A massive percentage of the regional breeding population extinguished in a single afternoon.
Faced with these overlapping crises, unintentional pharmaceutical poisoning in Asia and intentional pesticide poisoning in Africa, conservationists had to heavily intervene. You can't just ban a drug and wait. You have to physically feed the surviving population safely.
And here's where it gets really interesting. Because the logistical execution of this intervention led to the creation of formal vulture restaurants.
The term sounds, somewhat whimsical, but the reality is an intensely rigorous, scientifically managed feeding program. Organizations like Vulpro have developed exhaustive operational protocols for these sites.
Because managing the diet of an obligate scavenger requires mimicking complex ecosystem dynamics. The site selection alone is an exercise in avian aerodynamics. You can't just drop a clean carcass in a convenient fenced-off valley.
Why not?
Because vultures possess high wing loading. They are heavy relative to their total wing surface area. They rely heavily on environmental energy thermal updrafts and strong headwinds to achieve lift, especially after a massive meal.
Okay, so if you put the restaurant in a valley,
If you establish it in a topographic depression or surround it with tall trees, a gorged vulture will be physically incapable of taking off. They will be stranded on the ground, vulnerable to mammalian predators. The sites must be situated on elevated topography with an unobstructed runway.
a runway, they literally need an airstrip.
Yes. They also rigorously survey the airspace for power lines because collisions and electrocution are a massive secondary cause of mortality for these large birds.
But the core of the protocol is the absolute sterility of the supply chain. The menu must be flawless. Any livestock euthanized chemically, like with barbiturates, is strictly prohibited because the drugs remain active in the tissue.
And diclofenac, obviously, is completely banned.
The restrictions even extend to the ballistics used if an animal was hunted. They explicitly ban the use of animals shot with lead ammunition.
Because of the stomach acid.
Right. If a hunter uses a lead hollow point bullet, it mushrooms and fragments on impact, sending hundreds of microscopic lead shards into the muscle. If a vulture eats that, the pH 1.0 acid instantly dissolves the lead.
Releasing a massive acute dose of heavy metals directly into the bird's bloodstream, it causes lethal neurological and renal damage.
The managers of these sites also have to artificially replicate the lost mechanical functions of the missing apex predators, which I found fascinating.
Yes, because without lions or hyenas to breach the tough hides of the supplied carcasses, the conservation staff must manually slice the animals open. They physically incise the carcasses to allow the vultures access.
They even replicate the bone-crushing role of the hyena. The Vulpro guidelines dictate that managers use mechanical bone crushers to splinter heavy femurs into fragments. This provides the essential calcium supplementation that the vultures historically got from predator kills.
It is an immense labor-intensive undertaking. But these restaurants are ultimately a stopgap. They are triage. They provide safe, caloric islands to keep the remaining birds alive while the systemic battles are fought.
Because the real victory in the Asian crisis required finding a safe chemical alternative for the farmers. They needed an NSAID that worked for the cows but didn't destroy the birds' kidneys.
And identifying that alternative was a scientifically agonizing process. They instituted a highly cautious 5-step testing protocol. You cannot simply test novel pharmaceuticals on critically endangered birds.
Wait, so what did that protocol look like?
Yeah. First, they assessed the pharmacokinetics of the candidate drug in cattle, ensuring it cleared the system predictably. Then, they tested for toxicity in common, non-endangered surrogate species like domestic poultry.
Okay.
If it passed that, testing moved to slightly more robust captive African vulture species. Only if the drug proved completely benign through all those stages was it finally tested on the critically endangered Asian species.
It was an exhaustive gauntlet. And prohibitively expensive, estimated at around $100,000 to thoroughly vet a single drug.
They tested ketoprofen, ibuprofen, flunixin, and almost all of them demonstrated varying degrees of renal toxicity in the birds. But finally, one compound cleared the protocol.
Meloxicam.
It possessed a different chemical structure that the avian renal system could successfully metabolize and excrete without triggering that catastrophic uric acid buildup.
With meloxicam validated as a safe and viable alternative, the Conservation Coalition finally had the leverage to demand systemic change. In 2006, the governments of India, Nepal, and Pakistan enacted sweeping legislative bans on the veterinary use of diclofenac.
The enforcement was challenging at first, particularly combating the illegal diversion of human diclofenac into the agricultural sector. But the bans fundamentally altered the trajectory of the crisis.
The free-fall decline of the populations has finally begun to plateau. In carefully managed regions, we're even seeing the first tentative signs of demographic stabilization.
It's a powerful demonstration of how targeted policy, backed by rigorous forensic science, can halt an extinction event.
And to truly understand what long-term coordinated intervention can achieve, we have to look at the European success story. We need to talk about the resurrection of the bearded vulture in the Alps.
This is such a great story. By the early 20th century, sustained hunting, deliberate poisoning, and the decline of wild herds had effectively eradicated the bearded vulture from the European Alps.
They were functionally extinct across the entire mountain range.
But in 1978, a coalition of conservationists convened in Morges, Switzerland, and they committed to a wildly ambitious strategy. They were going to entirely repopulate the Alps using captive-bred birds.
They didn't even have a wild source population to draw from. They scoured zoos across Europe, identifying roughly 30 individual bearded vultures living in captivity.
They essentially built a centralized, pan-European avian genetics registry. They matched individual birds based on specific genetic markers to maximize diversity and prevent inbreeding.
And the biological realities of the bearded vulture made captive breeding a grueling commitment. These birds don't reach sexual maturity until they are roughly 7 years old.
And when they do breed, they typically only fledge a single chick per year. Expanding a population from 30 individuals under those constraints takes profound patience.
But the methodology they developed for releasing these birds, the hacking process, was incredibly successful. They've released over 580 juvenile bearded vultures into the wild across the Alps in Spain.
And because of these sophisticated acclimatization techniques, the survival rates of these released juveniles are staggering. We were seeing 88 to 96% survival rates in the wild.
The demographic momentum has finally shifted. From total regional extinction, the Alps now support a robust, self-sustaining wild breeding population of over 60 pairs, plus another 55 pairs in Andalusia.
The population density is reaching a point where young birds are being forced to explore outward to establish new territories. We are now documenting bearded and griffon vultures soaring as far north as Germany and Denmark.
It is genuinely awe-inspiring. They took a species that had been eradicated from the landscape, carefully managed its genetics for half a century, and now those massive bone-eating shadows are sweeping across the skies of northern Europe once again.
It serves as the ultimate proof of concept. When we invest the resources to deeply understand their specialized biology, identify the invisible human threats, and commit to long-term solutions, we can reverse the damage. We can restore the biological infrastructure of the sky.
So we've journeyed from the sacred mythological altars of ancient Egypt, through the evolutionary marvels of extreme gastric acid and thermal regulation, into the intense forensic hunt for a pharmaceutical serial killer.
And finally, to the meticulously managed menus of vulture restaurants and the triumphant repopulation of the Alps.
The fundamental goal of this deep dive was to reframe your perspective. The next time you see a turkey vulture catching a thermal over a highway, or footage of a wake dismantling a carcass, You aren't looking at a grim symbol of decay.
You are looking at a highly sophisticated, impeccably adapted, and incredibly fragile biological machine.
They are the frontline guardians of ecological hygiene, quietly neutralizing the pathogens that threaten us, saving agricultural economies millions of dollars, and demanding absolutely nothing in return except our waste.
They are the ultimate unappreciated environmental stewards.
But the mechanics of their near destruction leave us with a lingering, deeply unsettling question to carry forward. We just spent an hour deconstructing how a single basic veterinary painkiller, diclofenac, managed to invisibly saturate a food web and nearly eradicate tens of millions of the toughest biological incinerators on Earth.
It wasn't malice, it was an entirely unforeseen consequence of modern chemistry interacting with complex ecological pathways. The diclofenac flowed seamlessly from the pharmaceutical lab to the cow to the vulture, causing systemic collapse.
Exactly. So I want you to ponder this. Every single day, millions of us consume complex synthetic pharmaceuticals, painkillers, hormonal contraceptives, antidepressants, heavy-duty antibiotics.
Those molecules don't simply vanish.
No, they don't. They are metabolized, excreted, and eventually flow out of our wastewater treatment plants and into local rivers, estuaries, and soil networks. If a microscopic trace of a single bovine anti-inflammatory could crash a continental ecosystem and inadvertently trigger a massive human rabies epidemic, what are the invisible everyday medications currently flowing from our own bathrooms doing to the complex, deeply interconnected biological networks in our own backyards?
It forces us to recognize that our biochemical footprint extends far beyond our own bodies. We are fundamentally tethered to the ecosystems we inhabit.
Keep questioning what you think you know. Look out for the unseen mechanics of the natural world, and we will catch you on the next deep dive.